we're going to use integration to find the area between the curves x minus 1 cubed and x minus 1. We're given no bounds, so we're going to have to find the points of intersection of these two curves. So the way to find the points of intersection, we're just interested in the x values of the intersects, is it would just equate the two curves together. So we want to find values of x that satisfy the equation x minus 1 cubed is equal to x minus 1. X minus 1 cubed being f of x, and g of x is equal to x minus 1. Now, a real no-no here is to divide by the unknown, because if you do that, you're going to possibly lose one of the roots of this equation. So, rather than dividing by x or an unknown, it's best to factorise, and to make it all equal to 0, we take the x minus 1 over. So we've got x minus 1 cubed minus x minus 1 is equal to 0. So we've made it equal to 0, now we're going to factorise, and what's common to both of these terms? X minus 1. What have I got to multiply x minus 1 by to get this term? It'll be x minus 1 squared. The minus comes down. What have I got to multiply x minus 1 by to get x minus 1? It'll be just 1 is equal to 0. So we've got two factors here. We've got x minus 1 and all of this second bracket, but we can further factorise this. This is of the form of a squared minus b squared, x minus 1 squared minus 1 squared, and that's the difference of two squares, and that's a minus b, a plus b. So here my a is x minus 1 and my b is just equal to 1. So the second bracket further factorises to x minus 1 times x minus 1 plus 1. And that will now be equal to x minus 1. X minus 1 minus another one is x minus 2. And x minus 1 plus 1 is just equal to x is equal to 0. So we then ask ourselves, what values of x make all this equal to 0? So x equals 1. X equals 2, we'll make the second one 0, and x equals 0. So these two curves, x minus 1 cubed and x minus 1, intersect at 3 points at 0, 1, and x equals 2. So in order to find the area, we've got two regions where the area will occur, between 0 and 1 and between 1 and 2. So the requested area that we're trying to find is equal to the integral between 0 and 1 of f of x minus g of x. Now, because by just looking at those we don't know which curve is going to lie, going to be greater than the other in this region between 0 and 1, to overcome that, if we just take the absolute value, because the area always has to be positive. If this actually happened to be a negative, the absolute will make it into a positive area. Plus, likewise, between the region of 1 and 2, so there'll be integral between 1 and 2 of f of x. Just keep them in the same order. Once again, in this region between 1 and 2, we don't know which function will have the greater value, either f of x or g of x, so we'll just do the absolute value of that as well. Alright, so they're in the same order. So it would probably help us to work out what f of x minus g of x actually is in terms of x. So f of x minus g of x, this will simplify the integration part. F of x is equal to x minus 1 cubed minus x minus 1. Using the binomial theorem, that'll be equal to x to the power of 3 minus, now because it's the power of 3, the coefficients go 1, 3, 3, 1, the third line of Pascal's triangle. So the powers of x go down by 1, the coefficient is 3, x squared, and then it would be plus times negative 1, so that would make that negative. And then the next coefficient will be 3, and then the powers of x go down by 1. And the reason why this is a plus is because you've got negative 1 squared, and that makes that into a plus. And then you've got minus 1. So I've expanded out that. Minus, now the minus with that bracket there, minus x plus 1 is equal to x cubed. Collect our like terms. Minus 1 plus 1 will cancel each other out. And you get minus 3x squared. And then plus 3x minus 1x is plus 2x. So that will help evaluating the f of x minus g of x in each of the integrals. So our area, going back, is equal to the absolute value of the integral between 0 and 1. Now instead of f of x minus g of x, I write x cubed minus 3x squared plus 2x dx. Absolute value plus, we're going to add the integral between 1 and 2 of f of x minus g of x. We've worked it out, you only have to repeat it here, minus 3x squared plus 2x dx. So we're using absolutes because we're not sure whether f of x or g of x is going to be greater, and so these will both end up being positives. Okay, so now we can do our integral. We'll keep our absolute value. The integral of x to the power of 3, add a power on that power, minus. Now 3x squared will be x cubed on 3. The 3's will cancel, so that'll just be left with x cubed. And then the same with this one here. So you got add a power. So it's already x to the power of 1, so it'll be x to the power of 2 over 2. The 2's will cancel, be x squared. Now that one is going to be between 0 and 1, absolute, plus the integral we've already worked out. So it'll be x to the 4th on 4 minus x cubed plus x squared. Now this one is between 1 and 2. And we can do the absolute value of that as well. Now we can substitute in. We put in the 1 value first, so that's the absolute value of 1 on 4 minus. We're putting in 1, so it'll be minus 1 cubed, which is 1, plus 1. So that's putting in 1 minus putting in 0 is just going to be, all those terms will be equal to 0. Plus. Okay, we've got to put the 2 value in here first. So it'll be 2 to the power of 4, which is 16 over 4, minus 2 to the power of 3, which is 8, and then plus 2 to the power of 2, which is equal to 4. So I've put in the 2 value, minus, and now I've got to put in the 1 value. Now the 1 value I've already put in up here, which is just equal to 1/4 minus 1 plus 1. Okay, simplifying, collecting like terms, minus 1 plus 1 is 0. The absolute value of 1/4 is just equal to 1/4. Plus, this one might take a few more steps. 16 on 4 is 4, plus 4 is 8, minus 8 is 0, so all that becomes 0. And then the absolute value of plus 1 minus 1 is 0, so that'll be just the absolute value of minus 1/4. Is equal to 1/4 plus another 1/4, which is equal to 2/4, which is equal to 1/2. Okay, so let's have a look at the process we did. Find the area between curves. When you're finding the area between curves, it's an integral question. We've got to actually find the values of x where the two curves intersect, so we do that by equating the two functions, making it all equal to 0, getting it all over to one side, and then going through and factorising. Do not divide by x, or x minus 1 in this case. So that allows you to work out the points of intersection where these graphs cut. So we're going to have regions. So the graph, something like So here we have a value of 0, 1 and 2, x equals 0, x equals 1 and 2. So we've got these two regions which we're actually trying to find the area of. So to find the area, if we use the absolute value, we don't have to worry about whether we make it g of x minus f of x or f of x minus g of x. We just find the absolute value, and that will account for the fact that area has always got to be positive. It also simplifies finding the single function of f of x minus g of x. So we actually found that function, simplified as much as possible, substituted in there. Between 0 and 1 is our first region, and then between 1 and 2 is our second region. Be very careful with signs, because you've got one minus the other. It's going to make signs. Negatives become positives, positives become negatives. But by using absolute values, both of these areas become positives, and we add them together to get equal to a half.